Assalamualaikum. I will explain FERMAT's principle about reflection. FERMAT's principle explains that light follows the path of at least time. Of course, the straight line from A to B is the shortest time, but suppose it has a single reflection. The law of reflection can be derived from this principle as follows. So this is the diagram of the reflection. Since the speed is constant, the minimum time path is simply the minimum distance path. This may be found by setting the derivative of L with respect to x equal to 0. Now I will explain using the diagram I have drawn. So this is the angle of incident and this is the angle of reflection. This is the height of the incident and this is the height of the reflection. This is the length of the incident and this is the length of the reflection. So for the path length, square root a power of 2 plus x power of 2 plus square root b square plus d minus x square. FERMAT's principle states that the derivative of L with respect to x equal to 0. So the derivative of L over the derivative of x is equal to 0. The derivative of L with respect to x is 1 over 2 times 2x over square root a square plus x square plus 1 over 2 times d minus x times negative 1 over square root b square plus d minus x square. And then we can cancel these 2 and we will get this minus this equal to 0. So sine angle of incidence is x over square root x over square root a square plus x square, and the sine of angle of reflection is d minus x over square root b square plus d minus x square. So this is the sine angle of incident and this is the sine angle of reflection. Then we write it like this, and the conclusion is sine theta incident equal to sine theta reflection. So this is the law of reflection.
Assalamualaikum. Today I will explain about FERMAT principle and refraction. It states that Snell's law can be derived using the derivative and make use the index of refraction formula, which is n equal to c over v. So we can start the derivation by using the total time taken by the light to propagate from A to B. When we want to find the time taken, we will divide the distance by the speed to get the time. So the distance, we can divide the distance into two parts, which is from A to O and from O to B. And when we want to find the distance from A to O, we simply use the theorem Pythagoras concept, which is a square plus x square square root. So this is the expression, the distance from A to O. Distance from A to O. And the second part is we can find the distance from O to B, which is the b square plus the square root b square plus d minus x square. Then when we perform the derivation, when we find the dt over dx for the distance from A to O, we will get x over square root a plus x square. Then for the distance from O to B, we will derive and we get minus dx over square root b square plus d minus x square. And we know that the index of refractive is the where n equal to c divided by v, which is the ratio of speed of light in vacuum and the speed of light in the medium. So when we want, we will use the expression where v1 equal to c over n1. And for the second medium, we will use the expression v2 equal to c over n2. And it is actually when we derive the distance from A to O, it is actually the sin theta 1. Where sin is, we know that sin is equal to, sin theta 1 is equal to opposite over the hypotenuse. And we can see opposite. Opposite is the line here and the hypotenuse is here. So the first the opposite, the length of opposite is x, and over the hypotenuse is a square plus x square and square root, which is the distance from A to O. Okay. And same goes to the sin theta 2. Sin theta 2 is actually the derivation of distance O and B, which is sin theta 2 equal to x over b square plus d minus x square. And now we will multiply the derivation of the distance A to O and the distance O to B with the speed of the light in the medium. So what happens is we will x square root a square plus x square times with 1 over v1, which is the speed of light in the medium 1, and the derivation of the distance O to B times with the speed of the light in the medium B, which is d minus x over b square plus d minus x square times with the speed 1 over v2, speed in the medium 2. And with the information that we get from here and sin, we will substitute all the information to form the equation, and it will become sin theta 1 times with 1 over v1, which is equal to n1 over c minus sin theta 2 multiply with 1 over v2 is equal to n2 over c. And we will take equal to 0 as we derive as the function of the time equal to 0. And lastly, we will arrange the equation. Then we can cancel the c as it is the same expression. So it will become n1 sin theta 1 equal to n2 sin theta 2. And lastly, it will become n1 over n2 equal to sin theta 2 over sin theta 1. And this is all how we can get the Snell's law from the FERMAT principle. Thank you.